This is the first lecture on Chapter 5, which is discrete probability distribution. Our first section is 5-1, which is the probability distribution. So what we need to do is we need to tackle the vocabulary first. So Chapter 5, it's discrete probability distribution. So I want to outline the word discrete. Discrete variable means that the values are distinct, separated, with nothing between the two consecutive numbers or variables. For example, a family has 2 kids versus 3 kids. You cannot have 2.5 children, not unless you talk about this as some kind of a mean that doesn't actually make sense. So you cannot have something between 2 and 3 kids. Now, on the other hand, if we are talking about a continuous variable, it does make sense to have something between 2 and 3. For example, we're talking about heights of children. So is it possible to be somewhere between 2 feet and 3 feet? Well, yes. And there's infinitely many numbers between 2 and 3. So what this book has done is they divided the discrete probability distributions into Chapter 5, or they've allocated all of the discrete probability distributions that we're going to study in Chapter 5, and they have moved the continuous probability distributions into Chapter 6. So once we finish with discrete ones, then we'll talk about continuous, and our most important continuous probability distribution will be the normal distribution, which will be the majority of the semester. Now, a random variable is a variable whose values are determined by chance. So pretty much anything that we have studied in Chapter 4 is good to go. Any of the sample spaces are good to go. We're going to talk about some rolling dice and picking cards, but really it's more of a theoretical distribution. It is more of observational distribution, so we can talk about probabilities of having rain or no rain, probability of different kinds of weather, probabilities of different kinds of games, where you need to come up with some of the distributions, as some of the probabilities within the distribution. So a discrete probability distribution is just a way to summarize things. So usually it's a table. Sometimes we refer to it as a histogram if we want to see stuff. So this is why we studied stuff in Chapter 2, is so that we can organize ourselves. A probability distribution, a discrete probability distribution will be a table that has a bunch of values for a variable, like 1, 2, 3, 5, 6. So it's no longer classes like we did with histograms. And instead of frequencies, we're going to talk about probabilities. So Chapter 2 touched a little bit on relative frequency distributions, which we haven't covered in class, although some of you have done some homework on it anyway. But what the discrete probability distribution is doing is just that. We're going to organize our classes, except they're not classes anymore. They're values of that random variable, and we're going to give it the probability of that happening. So there's 2 words that I need to kind of for you to recognize. It's either theoretical or observation. So you can talk about rolling dice, where it is a theoretical distribution. Or you can talk about physically playing a game and then counting how many times you have scored a 6 or scored whatever it is that you're looking for, and get the probability just by observation. The only requirements for probability distribution is that you have accommodated for all of the variables. So having a complete sample space is very useful. You will find this out whether you have everybody or not by adding up all of the probabilities that you have described in the table, and they should add up to a 1. Otherwise, you are missing something. And each of the probabilities cannot possibly be anywhere outside of the interval from 0 to 1. So everything is a 0 point something, positive 0 point something, and this is a complete description of that table. If necessary, you can always graph those or place the values of your variable on the x-axis horizontally, and then place your probabilities on the y-axis vertically and construct the probability distribution using a histogram so that you can see the actual distribution, whether it looks about symmetric or maybe it's skewed to the left, skewed to the right, uniform, or all the other words that we have learned in chapter 2.